Welcome to FS ISAC, IBM, and ArcSight Technologies presentation of mobile payments, protecting apps and data from emerging risks. I'm Brant Hetherington, Marketing Director at ArcSight Technologies, and today's presenters are Tom Mulvihill, Mobile Security Strategist at IBM. Tom is an established security professional with over 25 years of combined product management, product marketing, and development experience. He's worked with a wide range of customers to define and deliver new products for both startup and large companies. For the past 8 years, Tom has focused on application security and helping organizations develop secure web-based and mobile applications. He is currently focused on advancing IBM's mobile security strategy. Our other speaker today is Winston Bond, Technical Manager at ArcSight Technologies. Winston is ArcSight's European Technical Manager and works with a wide variety of businesses, from large banks and oil companies to emerging startups, helping them to protect their code, data, and keys against reverse engineering, tampering, and theft. He has over 20 years experience developing low-level software on a wide variety of embedded, desktop, and mobile platforms. He has been with ArcSight for 7 years and is one of the leading experts in key and application protection. Today's agenda includes mobile app and payment landscape, how criminals can attack your app, comprehensive protection techniques, and finally, we'll have some time for Q&A at the end of the presentation. Before we get started, I'd like to remind you that you can submit questions for our presenters through the Questions tab on your dashboard, and if time permits, we will address them at the conclusion of the presentation. Any questions we don't get to will be addressed offline. Now we'll go ahead and get started. Gentlemen, take it away.
Great, thank you very much, Brent. This is Tom Mulvihill, and I'm going to kick things off by focusing on mobile app and the payment landscape. Next slide, please. Now, if we look at mobile banking services, we all know that security could be a competitive advantage. Banks and financial services companies spend a lot of money on customer acquisition. This puts added pressure on retaining customers, and mobile capabilities are a key consideration. Let's look at a few data points. First, in terms of millennials, 18 to 20-year-olds, 43% have used mobile banking apps in the past 12 months. I don't think that's really a surprise, and in many ways I think that's a pretty conservative estimate. However, 19% of customers won't do mobile banking because of security fears. So in the back of many people's minds, security is a key important factor. 90% of mobile banking app users use apps to check their account balances. The important takeaway with that data point, of course, is that even if customers are just checking their balances, they're not executing transactions, the risk is still there because they'll be using their login credentials to access their account information. So the risk is there. Next slide, please. However, as mobile grows, mobile banking grows, so too grow the security threats. Here are a few data points, supporting data points. First from McAfee, where they identify almost 400 new threats, and those threats are malware threats, mobile malware threats, every minute. In fact, in this report, there's a reference to them identifying almost 500 million malware threats by Q3 of this year. ArcSight did a wonderful study, and they do a study every year focusing on what happens to the top free and paid mobile applications, and they've identified that many of them, and it doesn't matter what the platform, Android or iOS, have been hacked. This is why Gartner argues that security testing, not just building it secure, but protecting it once it has been built, protection of mobile applications and data become mandatory. It's not an option. This is a requirement. Next slide, please. About a year ago, IBM was working to better understand where the market was, where our customers were, where our prospects were in terms of their maturity regarding developing a mobile security strategy. And perhaps not too surprisingly, we learned that many customers focus on device, many customers focus on secure content, many customers focus on developing secure applications. Again, this is a trend. This is where they're working to adopt technologies. However, we were surprised that only 32% were concerned about fraudulent transactions. And this was really telling, given the concern for a financial application such as banking or any type of financial services application. Fewer still, only 18% can detect the risk associated with jailbroken or rooted devices or mobile malware. Next slide, please. Security is front and center. We know that. And what's changed over the last couple of years from a financial services perspective is really that initially security was promoted as a differentiating feature. You can see the highlights in many of the market-leading capabilities today from many of the different banks. However, security has now emerged to become not a differentiating feature, but a requirement. I don't think anyone would consider using or banking or using a mobile banking app unless they were assured that the app is secure. Next slide, please. However, you're only as strong as your weakest link. And let's look at some of the challenges here and where there may be some weak spots in your whole adoption of developing financial services or mobile banking applications. First, let's talk about application risk. There's a risk from application hacking, and that's the risk from mobile malware, and that's really the risk associated with application security vulnerabilities. Historically, or more recently, I don't think you have to convince any organization of the need to protect their web-based applications. You shouldn't have to do the same thing to protect your mobile applications. There's an organization called OWASP, the Open Web Application Security Project. I'm sure many people are familiar with it. And historically, they've focused on looking at the top 10 vulnerability risks associated with web-based applications. Now they have a comprehensive report available focusing on mobile risks. And I encourage everyone to go take a look at that. But once you build an application, it's not just enough to build it securely, you have to keep it secure. You have to prevent it from the malware and prevent the applications from being hacked and exposing sensitive IP. And that's where the protection technology from ArcSight comes in. Now, concerning device risk, this is an often overlooked component from a security perspective. And the IBM survey really was a proof point that people really don't understand yet the risk associated with rooted or jailbroken devices. Part of the challenge in this context is that for principally business to consumer applications in this context, there's no way to manage that consumer device. So you can't employ enterprise mobility management solutions to help you deal with information, sensitive information on that device. You can't delete applications, you can't wipe data from those devices rather, because you're not managing them. And the challenge is when a device is rooted or jailbroken, the mobile operating system security controls are effectively removed. And this makes the content and the data and the applications on those devices very susceptible to malware. Another risk is associated with session risk. Well, what's an example of session risk? Well, session risk is many, many different things, obviously. It is the connection or the session with that particular use of a mobile application. An example of a session risk might be an insecure Wi-Fi connection. Perhaps you're doing some banking from a local coffee store, and there's a risk because that network may not be secure. There may be man-in-the-middle attacks. There may be people sniffing your Wi-Fi connectivity. All types of session risks also have to be considered when you're providing an opportunity for your users to access sensitive information or perhaps execute financial transactions. Next slide, please. All right, now I'm going to turn it over to Winston. He can focus on how criminals can easily attack your mobile banking apps. Winston?
Hi, thanks, Tom. So yeah, can we move on to the next slide, Grant? Thank you. So yeah, this slide shows the disruption that we're seeing, and I think everybody in the industry is seeing, of the model of engagement with, well, in this case, financial services in particular. We've been we're used to the last 10 years, 15 years of web apps, and security is all about keeping the server safe, installing things on the server, having a big fence around it, and potentially scanning your server application to make sure there aren't any vulnerabilities or side channels into it. But we've now moved into a world for the last few years where a significant part of the system is put into the hands of the end user. You can't have a web application security model with a 20-digit passcode and your grandma's birthday to type in on a mobile device. You have to put some intelligence into the mobile device, or it's going to be a very unpleasant user experience. So that means that part of the trust model moves on to the end application and is available to be attacked. And of course, Internet of Things and increasing numbers of sensitive applications having part of the system in end devices mean that those threats are ever more or become ever more important. So not only does you have to build your application securely in the first place, you have to keep the parts that are in the hands of the end user secure. They have to, those apps have to be able to look after themselves against somebody who's trying to take the app apart, change it, and put it back together again. Can we move on, please? Thank you. So yeah, there's two sides to this risk, as I just mentioned. There's the confidentiality risk of trying to stop somebody extracting the secrets from an app, potentially baked-in login credentials, which is I'm sure the textbooks would say it's a bad idea, but it does happen. Or crypto keys being in those applications, or even things like jailbreak detection, where where people will try to understand how that works so they can bypass it. Integrity risk, that's the next step in the process, where somebody now understands how the program and the system works, and they want to change it. So they go ahead and change the code. They don't need to do long-winded side channel attacks like SQL injection and Stack Overflows if they can directly change the code. So that's what people do. Can we move on to the next one? Thank you. So for code, that's a particular threat, and then your code is open, and a particular place where things are of concern is around cryptography keys. There's lots of examples with where cryptography keys have been extracted through through scraping the memory of programs. And the reason people use cryptography is because they believe that it will secure their data. That's the whole point. But your data is only as secure as your keys are. If people can find the keys, then they can break the cryptography. So having access to the application, having cryptography keys, being able to read crypto keys in memory, makes the system vulnerable to attack. As it says at the bottom of the slide, 80% of respondents to a survey identify broken crypto as the most difficult risk to minimize. That's probably because many of those people don't understand cryptography and how to implement a good system. Can we have the next one? Okay, so the next slide, please. Thank you. So as we've just how does somebody actually go about attacking an app on a mobile device? It depends exactly on the platform, the steps they need to take, but roughly, it goes through a flow like this. So the first step is to decrypt the mobile app. So if you may be aware that that iOS applications are encrypted. So if you go looking in the iTunes cache on your computer, then you won't be able to understand the code that's stored there. But it's not very difficult to decrypt that. There are freely available open source tools that will decrypt those mobile apps and produce binaries that can be analyzed with normal programmers' reverse engineering tools. So that's the first step for iOS. There isn't that kind of step for Android. You simply unpack a zip file and you have access to the code. The step 2 in the process is you open up and look through the app with again freely available tools, which will to somebody who understands what they're dealing with, will show them how the program works and reveal its secrets. The third step, if it's necessary, is to create a modified version of the app, repackage it, and then redistribute it to people. And once something's redistributed, it has a life of its own. It will go around the world and continue to live. And this process happens all the time, to lots and lots of applications. As Tom mentioned earlier, we have a report into the state of the app economy that describes how prevalent these kinds of attacks are. And I think if we move on, we now have a short video that shows how to do this on an Android device or for an Android app.
There are a number of different approaches that hackers are leveraging to hack unprotected applications. These approaches involve free tools and often can be performed within a few hours or less. Over the next minute or so, we'll illustrate one of the ways that hackers are attacking applications. The goal of reverse engineering is to recreate original source code as accurately as possible. This source code represents the payment processor loaded within a mobile banking app. We are interested in taking the final binary form of the code and getting source code to as close to this as possible. To do so, we will first convert the Android app into its Java bytecode equivalent using the freely available tool text-to-jar. This tool produces a set of Java class files stored within a jar. Next, we use JDGUI to create what it thinks is the original source code based on the contents of this jar. Using these freely available tools, the reverse engineered code for the payment processor is a remarkably accurate recreation of the original code. An attacker will leverage this to conduct further attacks against the application.
So I think Tom will now take us through some ways that we'll start to talk through how we can address this problem.
Great, thank you very much, Winston. I appreciate that. One of the challenges when you talk about mobile security more broadly is that it encompasses many things. It typically is comprised of many different products, many different technology, many different concerns. Mobile security is typically not a single thing to most organizations. In understanding what customers were saying in terms of their feedback to us, IBM put together the mobile security framework to look at mobile security more holistically, to look at it from an end-to-end perspective. Just to share with you, this framework is based in part on the survey we did and feedback from our customers and our prospects, and it starts with protecting mobile devices. This is where many people start. In fact, this is where a lot of organizations start. When you ask them about mobile security, they think in terms of mobile device management, and that is principally about managing BYOD programs in an environment where there are multiple operating systems. It's all about mitigating the risk of lost and compromised devices. The number one IT and security team concern is a lost or stolen device. And why is that? Even in a BYOD environment, as an employer, I don't have to compensate the employee for that lost device. They're concerned about lost devices, obviously, because of the data on those devices. In terms of maturity, or where many organizations go next, is they progress from managing or protecting devices to providing secure content and secure collaboration. This is really the cornerstone of what is more broadly defined as enterprise mobility management. Mobile device management is really a component of the broader enterprise mobility management solution space. Now, in terms of providing secure content and providing secure collaboration, this is anchored by the requirement that the user data and the enterprise data be separated and be segregated. And this is all about providing secure container technology and allowing you to put together your security best practices and policies that reflect how you want to enforce things organizationally. Next, there's the challenge of safeguarding applications and data, and this has multiple dimensions. And I'm going to talk about A couple examples here. First, the challenge is distributing and controlling enterprise applications. This is really about mobile application management, whitelisting and blacklisting applications. But as we've discussed a couple times in this presentation already today, it's incumbent upon organizations who are developing their own applications to first build them securely, and then once you've built them securely, to protect them in the wild. From there, we progress to managing access and preventing fraud. And access is more broadly defined than just a user accessing enterprise content. It's all about secure access to APIs that many mobile applications use and meeting the ease of use expectations from end users. Now, this is all tied together from an IBM perspective by extending security intelligence to the mobile platform. What is it that is unique about what's happening with those mobile applications that can be correlated with all the other data points? The reality is that many IT organizations, many security teams don't have the people in place to manage all the information or understand all the information they're collecting. That's why you need a security information and event management system that's now extended to the mobile platform. Next slide, please. And when we think of business imperatives for managing access and fraud, there are a number of data points that really highlight the need. I think the one in the bottom right really says everything you need to know in this context for this audience, where 95% of financial services incidents involve harvesting credentials stolen from customer devices. What's happening today is they're not necessarily using the mobile applications to gain access to information. What they're doing is they're targeting the mobile platform and the mobile applications. They're using malware, Trojan spyware to access or otherwise infiltrate or collect interesting information from the mobile applications, principally the username and passwords, and then they're using that through other channels such as the web-based versions of those applications to access the account data. Next slide, please. Now, when we're talking about building, testing, and securing mobile applications, a few things to keep in mind. First, again, you need to test the application. You need to identify those vulnerabilities. And in the context of the IBM portfolio, we have a broad portfolio of protection technologies anchored by our AppScan family of products. When it comes to protecting those applications once they've been developed, we leverage and rely on our partner ArcSight for their technologies to make tamper resilient those applications that are then released. And then, of course, in terms of securing the application data and safely distributing applications, this is anchored by IBM's Mobile First Protect technology, and there's lots of options and ways you can protect the app and data, from app wrapping to integrating a special SDK to prevent the sharing and exchanging, the copying and pasting of information within information inside a secure container. Next slide, please. Now I'm going to turn it back to Winston, and he can provide some additional information. Winston?
Yeah, thanks, Tom. Yeah, so absolutely. So the big question is, what can we do about this? We understand there's a problem, and the applications in end devices are vulnerable. How can we stop somebody taking them apart? So the first step is, as the slide says, can you say obfuscation? It's a very obfuscated word that's difficult to say and even harder to spell. So what's that all about? That's about confusing your hacker. So in a lot of cases that turn, or the simple version of it is you just change the names that get embedded in the binary to make them harder to understand. The more sophisticated approach is to try and make the code itself into something that's harder to follow. So instead of having very regular, predictable sequences of instructions that compilers create, we scramble them up, make the code much harder to follow, make it much harder to understand the functionality, so that decompiler that we saw in the video no longer can understand the code, can no longer produce legal, easy to read source code. It just produces instruction or machine instruction level results, which are almost or very difficult for anybody to follow. So that's the first step in the process, and that's something that ArcSight tools can do, of course. The next step, if we move on, please. Now, other things we can do. So here so method renaming I mentioned. So that is the technique of changing the names of the items that are inside the code, which in iOS programs and in Android Java programs, those names get embedded into the binary, so that the decompiler or someone trying to reverse engineer the code gets a great view of what's going on. So in this example, we have a symbol called jailbreak detect, which is very easy to follow, very easy to understand. The programmer has been a very good engineer, and he's given things a sensible name, but that also gives the attacker a good hint on where to look. After our protection process, the name's disappeared. We've turned it into a set of binary characters that nobody will understand. The second example, string encryption. Again, in our program, we have some predictable string or some easy to find strings. There are just sequences of text characters that there are tools available that will dump those from the program. And again, those give people a really good hint on where to look. If you're, in this case, we're looking for the word jailbreak, up pop 3 strings that tell us which are the error messages. So someone trying to understand the code would know exactly where to find, where to start looking for the jailbreak detection, because he can see what happens, or the messages that get printed out when a jailbreak is found. After our protection, the strings are encrypted so that you won't find them in the binary. Next slide, please. So in here we now talk about what can we do about changing the code. It's one thing to understand it, but what about if someone changes it? So there's several techniques we can use, or we do use here. One is checksums. So we carry out a calculation on some area of the code, and when the application is built, we know what the answer should be. If anything is changed, or if the result is different when we run the check at runtime, we know that the program's been changed, and we can do something about that. So in that case, the tools let the application developer decide what to do. He can crash the program, he can send a message back. It's up to him. Or debugger detection. Again, we want to know if somebody is trying to debug the program. That's another step towards trying to understand it and trying to change its functionality. So we can insert debugger checks anywhere in the program. Swizzling detection is a particular technique for taking over the functionality of Objective-C iOS applications, where an attacker can override the functionality of something. For example, the jailbreak detection with their own version, without actually changing the code. So we have techniques for detecting that. All of those, the result is, if we find a problem, the app developer wants to be in control of what happens next. So we give them that control. So can we move on to the next slide, please? So that we've covered a few different techniques that can be implemented to protect the code. There's a whole range of these different things that we won't go into today. We have a range of different protection techniques which defend the application against being compromised, detect when it's being attacked, and then react to those kind of attacks to defend, to keep the app resistant to tampering, and keep the system safe. All of the different types of guards, as we call these protection techniques, can all be applied in a customized way that's specific to the requirements of each application. Every application has got a different mix of requirements of things that need to be kept secret and things that need to be prevented from being changed. And they can all be applied in ways which minimize the performance impact. Next slide, please. Key protection, we mentioned earlier on that cryptography keys are very important in many systems. So ArcSight has a key protection toolkit which implements white box cryptography. So the intention there is that, or the way that works is that the standard normal cryptography algorithms, things like AES, RSA, DES, elliptic curve, are implemented in ways which get the same results, but which use keys that are in a very different format to the normal kinds of implementations. So that if someone wants to understand what those keys mean, they have to do a lot of complex reverse engineering of the code, and then they have to do a lot of complex maths to understand how the things they find in memory correlate to the crypto keys that they expect to be seeing. So that's a very powerful technique for preventing reverse engineering and modification of keys, and it's widely used in many cryptography applications. If we move on to the next slide, please. That talks about the different formats we have that this library has for data. So there's the classical; it can handle data in the normal, in the clear format that that every cryptography library can cope with. It has a special obfuscated format where the data is scrambled with low performance impact, simple ciphers. So that typically is used in between algorithms so that data can't easily be dumped from memory. And then finally, there's the maximum security white box form for keys, which needs a maths PhD to understand. And you also have to understand have to be able to get through the reverse engineering protection. Can I see the next slide, please? Can we see the next slide? So the way that works in practice is that the first step is to pass the standard crypto key through a translator to produce the white box form key, and that can either be done on a server in advance or it can be done in the application on the fly. It's optional, and there are pros and cons to either that we can discuss. Then the special cryptography library gets compiled into the application, and as the second step. Third step is it gets protected with the guards, the anti-tampering and anti-reverse engineering protection. Step 4, the application gets sent out into the wild and will look after itself when people try to extract the crypto keys from it. The next slide, please. So overall, I guess we've done a very quick run through ArcSight's tools for protecting against reverse engineering and tampering, and the key protection tools. Why choose ArcSight? Because both the binary protection and the key protection tools offer gold standard protection strength, the best you can get for software security. They're all implemented with, the application protection is implemented without disrupting the software development life cycle. We have lots of large customers who typically have hundreds of people in their engineering teams, but only a handful who have to deal with the protection tools. Key protection, again, it's very good, very high standard of protection and easy integration. The library that a user gets delivered feels very familiar. It looks just like an OpenSSL cryptography library with some special functions added. Everything we do is very well proven, deployed on over 400 million devices now. We support all the major platforms, all the mobile platforms, all the desktop platforms. We have a strong IP position, and of course a strong partnership with IBM's security division.
Great. So thank you very much, Winston. I'd like just to talk a little bit here now in terms of the relationship between IBM and ArcSight. ArcSight, as I mentioned earlier, is a very special partner with IBM. IBM has many different types of partner relationships, but the relationship with ArcSight is different because IBM resells the ArcSight products and technology. It's what's referred to as an enhanced reseller relationship. That means that our sellers, our service providers, our support organization, we treat the ArcSight product like it is an extension of the IBM mobile security portfolio, and in fact, it is part of the IBM mobile security portfolio. That means from a customer perspective, if you were to work with IBM or ArcSight, likely you'd be working with somebody from IBM if you wanted to engage and find out a lot more about ArcSight or talk about how ArcSight might work with some of the existing IBM products. And in terms of working with the existing IBM products, ArcSight not only is a partner, but they have spent a lot of time working with the different development teams from IBM and very tightly integrating their product with the IBM products. The best example likely is the integration between the AppScan product, which helps you build a secure application, and then the ArcSight product, which helps you protect it. There are many other different examples in terms of integration with IBM Trusteer and the IBM Worklight, now IBM Mobile First platform product. An example of that integration would be the rules that have been provided by ArcSight to the AppScan product, which will allow you to scan your source code, so static application security testing, and identify those critical areas inside your application that are really in need of protection. So when you release that mobile application, you make sure it's protected. Next slide, please. Brent, I'll turn it back over to you now. Thank you.
Okay, well, we want to thank both of our speakers for that fascinating and valuable information. We'd like to show you here some offers for webinar participants. We have a free evaluation of ArcSight application protection for IBM solutions, which, as Tom mentioned, is offered as part of IBM's security portfolio. So for more information, please contact your IBM representative or email ibm@arcsan.com. And then we have a few additional resources for you. Here we have links to some videos on how to hack an app. And second, we have 2 white papers we're offering, an IBM white paper, Old Techniques, New Channels, Mobile Malware Adapting PC Threat Techniques, and the ArcSight and IBM white paper, Securing Mobile Apps in the Wild. As a reminder, attendees will be receiving an email link to the recorded version of today's events, and that link will also have links to some of these other resources. And we now have time for some Q&A. We've had a few questions come in over the dashboard during the course of our presentation. So we'd like to start off with number 1. One of our viewers asks, why is all this attention being given to mobile application security, and what's the difference between mobile and web application security? Tom, do you want to take that one?
Sure, Brent, happy to. I mentioned a little bit earlier that organizations fear that they might end up in the headlines regarding the latest breach. So they don't have to be convinced about securing their web applications. It's unfortunate that increasingly they do need to be convinced to secure their mobile applications. And one of the challenges and one of the big differences between web security and mobile security is that the perimeter, the network security perimeter, has moved from the enterprise to the device. Think about it. If I wanted to gain access to an organization's web-based application, I would likely need physical access to some server room. It's virtually impossible for me to gain access to that application and to experiment with it and to reverse engineer that, in part because of the network and the perimeter security around that application. Contrast that with what I need to do to access a financial mobile application. I can likely download it anytime I want, virtually any place on Earth. The application is likely free, and as Winston highlighted, with the readily available open source hacking tools, engineering development tools, it's very easy to reverse engineer that application because there's no perimeter. The perimeter has moved to the mobile device, and really there is no perimeter, and that's why you have to protect that mobile application.
All right, well, thank you very much, Tom. We have another question here, and this one I think is for Winston. Viewers asking, has an ArcSight protected HCE or mobile payments app been pen tested, and does it pass the current standard of security used for hardware approaches?
Yeah, I guess that's we didn't really talk much about that. The use of this kind of cryptography technology that we were talking about in payment applications is hugely important. We're seeing an awful lot of interest in host card emulation, paying for things with your mobile phone whilst they look like making your phone look like a credit card. And the white box cryptography is vitally important for that kind of thing. So the straight answer, simple answer to the questions is yes. We've done that. We have the appropriate badges to do that, and we'd be happy to talk to you about that.
Very good, thank you. One more question for Winston. What is the impact on performance, and how many have any major banks successfully deployed this approach?
Impact on performance first. That's entirely configurable. It's all it's not high, but it's tunable on by each developer to their own requirements. Everyone has goals and requirements for what they want, and they can each individual developer can make those trade-offs. The other question about do we have banks using this for real? Absolutely. I was looking through a list of the most popular banking apps in my country, in the UK, recently, in the last week or so, and I think we were in about half of them. So that still leaves an awful lot that aren't using this kind of practice. I should be clear that those were the most popular apps with consumers. Consumers like high-function mobile apps or mobile banking apps where the app on the end device does an awful lot of the heavy lifting and is really part of the login model, which means that there's an increased demand for security. So yes, we have a lot of customers doing that, and the people with the web-based sort of old-fashioned banking apps have some catching up to do.
Great, thanks, Winston. I think we've got one more question here, and I'll throw this one over to Tom. Is ArcSight protection complementary to the Trusteer solution?
Thank you, Brent. And the answer to that question is yes, it absolutely is. One of the use cases that is very much a challenge for financial services organization and banks is what I mentioned earlier, and that is providing mobile security on unmanaged devices. The primary use case here is a business to consumer application. You're not going to manage that device, which means there's a lot of security that you won't have control over. And in this context, the reason why the ArcSight technology is so complementary to the IBM Trusteer security technology is because when you use the Trusteer technology, there's an available Trusteer mobile SDK. And what Trusteer does, I should have stated up front, is identifies device risk. So the Trusteer technology can be integrated into the application logic of a financial services application. It can determine whether the device has been rooted or jailbroken. It can determine whether or not there's malware on that device, and then it can do some action or take some action or programmatically control access or prevent transactions based on that very sensitive, important security information. Now, where there's a complement and where there's some points of integration with the ArcSight technology is that this is very sensitive information. This is an area of information that you don't want to be exposed to hackers who try to reverse engineer your applications. One of the things they'll look to do is they'll look to see if an application has root or jailbreak detection on it, and they will look to shut that off. And the combination of Trusteer with the ArcSight technology will protect that information, it will obfuscate that information, and make it really impossible for the hackers to take advantage of all the great capabilities in terms of device risk that Trusteer can provide, and then ArcSight will prevent any hacker from turning that off.
Very good. Thank you very much, Tom. This concludes today's presentation. Any questions that we didn't have time to get to, as we mentioned, we will certainly answer offline. And we thank you all very much for attending.